world of calculus. So far, we have done numeric expression, alphanumeric expression. Today, we are going to look at algebraic expression, the last part of expression. I want to start with variable expression. After that, we move to nominal, binomial, trinomial, polynomial, and so on. Okay? So let's start the good job on variable expression. And under this, we're going to look at some derivatives, and then how to evaluate the word problem, how to simplify, and the relationship between the expansion and the factorization. And we're going to look at different types of variable expression. Let's get to work. Good. So, variable expression. The word of expression is, we know it already, algebraic expression. That's another word for this. And what is the meaning of this? This simply means the combination between the terms, and in between them we have an operation, and the operation can be addition, subtraction, multiplication, and division. What am I saying? Let us assume we have 6x plus 8, for example. This is called variable expression or algebraic expression. But inside this place, we have different types of components, types. For instance, we have, if this is 6 and this is a variable, this is a variable, let's write it there. This is variable. Any number beside the variable is called coefficients. These words are very important. We're going to make use of them very soon. Coefficient. And of course, what we have here is an operation. And this operation can be plus, as we have it, can be minus. If the this also there's operation here, but it's multiplication. Okay, we can also have division. It's possible. So this is very important. And the last terms we have here is called constants. Why? Because there is no variable. There is no letter beside it. So this is called constants. Now, all this thing we have here is called variable expression. Are we together? And of course, we can walk around with different terms. We can do some basic operations on all these lines. Okay? So let's go to an example and see how to solve this kind of problem. But don't forget, this is a variable, this is a coefficient, this is an operation, and this is a constant. All of them is called variable expression, or it's an algebraic expression. Okay, let's do example. Good. Now, problem is here. The question says, identify each terms. Now, this is very important. Terms. Each terms. We need the terms in the expression, and then identify the coefficient, the variable, and the constants. If any. If there is not, we leave it. So we have 4 things to identify here. We have 4 things to identify. First, term. We need terms. If any. We need coefficients. We need variable. We need variables. And we need constants, in case we have more than one. So, how many times do we have here? When the operation, addition or subtraction, separates variables or constants, this is called terms. For example, this is plus, this is plus. Okay, let's say this is minus. Doesn't matter. Let's say this is minus. So this is the first term, the second term, the third term, and the fourth term, which means we have 4 different terms. Let's number them. Let's number them. The first one is 9b. The second term is 15s squared. The third one is a, and the last one is minus 6. Minus 6. Now, we have 4 different terms. Now, from each terms, they ask us to write out the coefficients. The coefficient. So the first term, what is the coefficient? Coefficient, this is a number, this is a letter. So coefficient is a number beside the letter. So what is beside here is what? 9. So 9 is the coefficient here, and then the letter here is called variable. So for this place, there is no constants. Constant does not exist here. For the second term, 15s squared. 15 is a number beside a letter, so it's called the coefficient. This is a variable. The variable here is s squared because it's x that is carried the 2. S squared. And here also, there is no constants. This place, we have a. Very nice, a. Now, who can tell me the coefficient here? You're smiling. The coefficient here is 1. If nothing is written beside a letter, it means naturally it has 1. Because we believe that anything multiplied by 1 is that thing. Right? So this is 1, and then the variable here is a, and unfortunately, no constants. The last term, it's also a term, because it's from expression. So this is 6 minus 6. Minus 6. Minus 6. There is no letter. If there is no letter, there is no coefficient. Because there is no variable. So if there is no variable, there is no coefficient, it means what? It's a constant. It's a constant. So there is no this, there is no this. You see, it's very easy. How many times? 1, 2, 3, 4. And we list them out and we fill it again. Now, quickly, let's look at this one. How many times do we have here? 1, 2, 3, 4, and 5. And 5. If you like, we can draw the same thing we draw here. We have terms, because now we have more than 1. We have terms, we have coefficient. All these things are very important. But then we start the real work. Variable or variables, and then constants. So we can have our line as usual. How many times do we have? 5. So let us read them here. Terms. The first term here is a cube. Second one is minus 4a squared b. 3ab squared minus b squared plus 12. If it's plus, we can leave it. There is no problem. Now, coefficient here is what? Is 1. As I said before, it's 1. And then this is the variable. The variable here now is SA cube. Unfortunately, no constants. Of course, if these two exist, this does not exist. If this exists, this two does not exist. That is the logic behind it. Now, what's the coefficient here? A and B, they are variables. So the only coefficient here is minus 4. Minus 4. And the variable here is A, Q, B. Because letter. Variable represents letter. English language, the alphabet. And then no constants. Here is 3. AB squared. No. Minus 1. B squared. No. No, and 12. Okay, so you can take our workbook and solve more problems like this. Once you are able to identify all these terms, you can now move to the like times. Let me give you an example of like times quickly. Like times. Like time. What do you mean like time? That is something similar. For example, let's say we have 2x plus 4y plus 3x minus 3y. Like times, something that they are together, twins. Now let's look at it. This is x. Let's have another one. Make it a little bit complicated. This is x. It's only having x. This one is having y. They don't have anything in common. They're not the same. So they're not like times. But look at this one. X is here. We don't care about the coefficient, but we care about the variable. The variable here is x. The variable here is x. It means they are like times. They are like. They look alike. So these two guys can be joined together because they are family. Let's continue. Look at this one. Look at this one. This is y. This is y. It means these two guys, they are also like times. Like times. Like times. Look at this one. It's having x and y. We have no family here. This x is separate. This one is separate. This one have to stay together. You have no family. So it means that we can operate. We can operate these two together. This one will give us 5x. We can operate this together. This is 4. Since y is common, it's like times. So 4 minus 1 is 1. And don't forget, you need to write 1. So this will be what? Y. So if you want to put it together, the final result will be what? 5x plus y plus 7xy. This is the result after you must have joined the like times. And from here now, we can now write out the coefficient for x. Let me use short form. Term, coefficient, variable, but no constant, so forget about it. So it now look like this, right? So this will be the term here is 5x, y, 7xy. This is after the operation. Now we can write out coefficient. Coefficient is what? 5. So this is variable. This is what? 1, and this is variable. This is what? 7, and this is a variable. So we do the operation by joining the like terms. Like terms. The word like is very important. And then we do the operation and we write out our number. And we together. Nice. Good. Let's go to the next level. So now let's see another example. We have seen an example where we mix letters. What if it's the same letters? Are they still like time? Let's see. The first one, 7y squared plus 8y. Are they the same? No. This one is y squared. This one is y. They are the same letter, but they are not the same structure. The structure is not the same. But the next one, minus y squared. Now, this is y squared, this is y squared. This term, the same. This term are the same. So it's easy to join these two, this guy and this guy together. Now, the last one is 5y. Now, you can see now, it's fine its own family now. So this guy and this guy can be joined together. This is like times. Like times means the structure was the same, the letter was the same, everything was the same, except the coefficient. Coefficient is not compulsory. Coefficient is not compulsory. But the structure of the variables, must be the same. So let's conclude this. Now, collecting the like times, we have 7y squared. This is minus y squared. This is the same term. Plus 8y plus 5y. So you have collect them, you separate, you discriminate. Those of you coming from A this way, those of you coming from B this way. So you discriminate. So what do we have? So what is here is what? 1. So the coefficient now, you cannot operate the coefficient. Coefficient here is 7. Coefficient here is 1. So 7 minus 1 equals 6. 6 is like times. So just choose 1. And this one, y is the like times here. The coefficients here is 8 The coefficient here is 5. So the operation between them is plus. So 5 plus 8 will give us 13. And the like times here is y. This is y squared. This is y. We cannot operate them together. This is the finish. Same thing here. Collect the like times. Y is s squared. S squared. They are family. So you can say 11 x squared plus s squared. These are like times. Plus 8x minus 8x. These are also like that. So you can operate these two. What is here is 1. So 11 plus 1 was 12 x squared. And what is here is 8. Coefficient here is minus 7. 8 minus 7 is 1. And the like time is x. So you can say plus x. The 1, we don't write it because we know that it is there. And this is finished. Easy, right? Good. This is called the simplification of variable expression or algebraic expression. Now let us look at evaluation. How to remove these variables. We want to see only letters. Let's see how we can do. Good. So now let us look at evaluation. You see, we can see how to collect the like times, right? But when we collect the like times, the final result, we still have some variables. But what is the help of evaluating? Evaluating means we don't want to see the variable, we want to see the numeric, the number. So we want to replace the variable with a number. Now let's see the first example. Say evaluate x plus 6 when x is 2. So it means that anywhere we see x from this expression, we should just replace it by 2. So let's have solution. So the first one is 2. So instead of writing x plus 6, we write what? 2 plus 6, because we replace by 2. So let me just write it here. So 2 plus 6, and of course 2 plus 6 is 8. So this is finished. For the second one, replace x with minus 4. Anywhere we see x, plus minus 4. So we have this is x plus 6, so we have minus 4 plus 6. And minus 4 plus 6 is what? Is 2, right? Don't forget owing the money you have. So it's 2. This is not new. If it's don't understand, go and check the previous video. The last part, x plus 6. Now x is 0. So we have 0 plus 6, which is 7. You see, very easy. Let's look at another example here quickly. Now, t. We are replacing t now. We don't want to see t again. So anywhere we see t, we should put 2 at first. So if you put 2, that is the first part, we have 3. Replace t by 2 from the first part. So we have 2 squared plus 2 of 2 minus 4. So 2 squared is 4. 4 times 3 is 12. 2 times 2 is 4 minus 4. Obviously, this guy, we cancel this guy, and the final answer we have here is 12. It's very easy. Just replacement. Stand up from there, and another person replace it. Very simple. B. Now we should replace by -1. Anywhere we see t, we should replace by -1. So we have 3 of -1 squared plus 2 of -1 minus 4. So -1 squared, that is -1 times -1, that is 1, right? So 1 times 3 is 3. All this is what we have done before in numeric and alphanumeric. Okay? So to enjoy the world of calculus, you need to follow it in algorithm way, step by step. Okay? Plus minus is minus, and 2 times 1 is 2, and then minus 4. So this is 3. Negative, negative. So we have minus 2, minus 4, that is minus 6, right? And then you are owing 6. You have 3, that is 3. This is easy. Now let's move to the one that is, this is where I want to go, but I want to just get the foundation here so that you can know what's happening. Now we have 4 different variables. 4 different variables. We have A, we have B, we have C, we have D. So we want to replace them. Letters. We don't want to see the variable right here. It's our aim. So this is where we are going. It's very easy. Just replace. So anywhere you see A, just put 2. Anywhere you see B, put -1. C, put 3. D, put 1. Finito. So let's do that. So we have absolutes. A is now 2. B is now -1. Minus C is 3. D is 1. Everything divided by A is 2. So square like this. B is -3. You see, no more variables. All the variables disappear, replaced by numeric. Now we can now find the operation. Don't forget the board mass. Step by step. First, the bracket here, right? Open the bracket. 2 times -1 will give us -2. 3 times 1 will give us 3. Come to the denominator. 2 squared is 4. This 2 times 2, right? -1 cube. -1 cube means -1 in 3 places. -1 in 3 places. So minus is plus, plus minus is minus. So this will produce negative. And 1 times 1 times 1 is 1. So we have -1. So this guy reduced to this. Moving further, we have -2 minus 3. Is what? -5. Minus here become plus. So 4 plus 1 give us 5. Now, what is absolute? The magnitude of -5. They did like this. The law says the absolute value of negative change to positive, and then the absolute value of positive remain positive. Remember? Good. So this is 5, and then by 5, and the final answer is 1. So when you say, all this thing we have been doing, all this, so everything has become 1. That is mathematics. Are you happy? We are getting there. Let's move on. Good. Now, we want to look at expansion. Of course, expansion means you want to expand. So it means you have put them together. Now you want to make it separate. Don't forget the terms. When we work with terms, we have 2, 3, 4 more terms to work together. So let's assume we have something like this: 2 of x plus 4. Now, this is a factor of this guy. Now, to expand means use what is outside to multiply everything inside. It's called expansion. So, you have to multiply this by this, also this by this. Because this bracket means these two belongs to everything inside here. So, this will be 2 of x plus 2 of 4 to open everything inside. This is called expansion. Expand. So this will become 2x plus 8. From this expansion, another term can come out, what you call factor. Factor means what is common. Don't forget, we have done something like factorization of numbers before, but now we have letters now. Factor means factor out the common numbers or common terms, common variables, depends. For example, we have this guy now. We have 2x plus 8. Factor means what can go here that can also go in this place. This means factor. Factor out the common numbers of variables. So 2 can go here, 2 can go here. If you take 2 outside, this 2 is out. So what is left here is x. If 2 is out here, if 2 is out from A, what is left is what? 4. What is left is 4. Because 4, 8 can be expressed as 2 times 2 times 2, right? This 2 is out. So remaining, this is called factor. It's called factor. And don't forget, if this is 2 terms, so we have the first term, the second term. These are different languages we speak in the world of algebraic expression. Coefficient, constant, variable, terms, like times, factors, expansion, simplification, and so on. These languages are very, very important. Okay? Okay. Let's look at another example. Let's say we have 4s squared plus 6x, for example. This is already given to us as 2 terms. Now I want to factor out the common numbers or variables. So what can go here that can also go in this place? As you can see, this is 4. This is 6. So what can go in both 4 and 6? 2 can go here. 2 can go here. 3. So it's 2 that can go in both of them. So that 2 that can go, take it outside. Now we have x squared here. We have x here. If you write it x squared, x, what can go in both of them? X can go. If x goes here, it will remain only 1x. If x goes here, it will remain only 1. So it's x that is common to the variable. 2 is common to the coefficients. So if x is out, now 2 in 4 is 2. X in x squared is x. Plus 2 in 6. 2 in 6 is what? 3. X in x is what? 1. So 1 is there. What can I say? 3. And this is finished. So what we do here is called factor. We factor out the common coefficients and common variables. When we open this guy, it's now called expansion. So we can return this result back to this place. So multiply. 2 times 2 is 4. X times x, that is indices, remember? X power of 1 times x power of 1. X is common. We take only one x. 1 plus 1 is 2. Remember? Indices, index, exponent number. Math is very sweet once the foundation is solid. Okay, next 2 times 2, 6, and then x. And you see, we return back to this. So factor, expansion, there is a relationship between them. There is a relationship between the factor and the expansion. I hope it's clear, right? It's clear. All these are very important. We're going to make sure all this very, very soon. Okay? Let's say something more interesting. Good. So now we have seen how factor and the expansion are related. Now let's solve some problems. Let's solve more problems. Now we have some parentheses here. So which means we want to simplify it. Simplify means break it down. Break it down. So what is simplify this? To simplify this, we need to use expansion to expand this. When we expand this, we now collect the like times. Remember? We now collect like times, we finish the simplification. Very easy. So let's see. First, expand everything. Expand means remove the bracket. We don't want to see the bracket. So we have minus 5x minus 9, minus times 2x, that is minus 2x, minus times plus, minus, and this is 3. We have opened all the brackets. Now, our bracket is parentheses, right? We have opened the parentheses. Now, collect the like time. Those ones that look alike. Let's check. The variable that look alike. This variable here is x. There is no x here, so they have nothing related. Yes, x is here. So this guy and this guy, they are related. No x here. So it's like this guy and this guy, they are related. So combine the like times. Okay? We have minus 5x minus 2x. These are the like times. All the boys this side, all the girls this side. And we have minus 9 minus 3. This is the one without variable. So operating 5. Now you have to add, since they are common, we need to consider only the coefficients. So minus 5 minus 2 give us minus 7, and then the variable. Minus 9 minus 3 give us minus 12. This is easy, right? You just collect the length. Now, the second question. Also, open the brackets first. That is first thing. Open the brackets. To open the brackets, we have to use minus 2 to multiply everything inside this bracket according to this rule. Minus 3 to multiply everything. So, doing that, we have minus 2 times a. We have minus 2a. Minus minus will give us plus. 2 times 3 will give us 6. And what is here? Variable b. We have expanded the first term. The second one. Minus 3 multiply everything inside this bracket. So minus 3 times 4 will give us minus 12. Minus minus will give us plus. So 3 times 2 will give us 6a. Minus plus will give us minus. 3 times b will give us 3b. So we have opened the brackets. The next is what? Collect the like terms. Collect the like terms. The terms that are similar. Now let's check. The variable here is a. The variable here is b. They have nothing in common. The variable here is constant. It's not even variable, it's just constant. So these three are not the same, are parallel. Now a is here. So which means I can join minus 2a with plus 6a because they are having the same variable. This is b. This is b. It means I can join 6b with minus 3b. And minus 12 is only minus 12. We have no family. Unfortunately. So now, since we have collected the like times, we can perform the operation. A is common. We have a. So 2 minus 2 plus 6 will give us 4. And then the variable is a. Come here. bb, the factor is common. So 6 minus 3 will give us 3. That is plus 3b. And lastly, minus 12. And this is finished. Because this is a, this is b, this is constant. They have nothing. Now we have 3 times. Before we have 2, 3, 4, 5, 6. There are 5. That's a repeat to step. Are we clear? Good. Now I want us to look at word problem. If it's coming form of word, how can we interpret it mathematically? Ready? Let's go there. Good. This is very important. The word problem. Word problem is the problem comes in form of English language. Now we try to write it in mathematical form. And these terms are very important. When to use addition, when to use subtraction, when to use multiplication and division. Of course, we know that A plus B means add A with B, right? Plus. That one's easy. Now, the sum, the word small sum means addition. So the sum of A and B also means A plus B. So it's just another way of writing it. Another way of writing is A increased by B. That is A increase means addition. Addition. So A plus B. A increased by B. Still the same. B is more than A. Now be careful. B is more than A. More. That is, you are adding A to B. B is more. That word more means addition. You say less. Now, different thing. The total means sum up, right? Sum up. And A added to B, B added to A, or A added to B is simple. A and B added to A. That is, A exists, you now add B to it. All these words, it means the same expression. You see, just like you said, I am going to the market. I want to go to the market. Or I went to the market. Everything is what? He's going to the market. So this is the good things about mathematics. Now, when do we use subtraction? A minus, of course, we know. Another word for minus is subtraction. So A minus B. Be careful. A minus B. It's not the same with B minus A. Minus is very linked. For plus, you can use it interchangeably. Nothing changes. But for minus, you need to be careful which one comes first. The difference of A and B, that is the difference between A comes first, and B, A and B. B subtracted from A. Now, it means that A exists, but now removing B from it. A decreased. Now, A is reducing. So A is big, it's now reducing from B. So which means you are minusing B from A. B is less than A. It's not the same with A is less than B. B is less than, it means that B is not up to A. So we are minusing the smaller from the bigger. So all these terms still the same expression. Multiplication, of course, A times B. Very common, right? Or the product A for A and B. You can also use it interchangeably. You can say B times A is the same, right? So we can use A dot B, A parenthesis B, parenthesis A parenthesis B. They are all multiplying. And lastly, division. A divided by B. That is, A is up and B is down. The quotients of A and B. Quotient means division. Quotient rule. You get the ratio. Quotient means division. The ratio means A ratio that is divided by B. And lastly, B divided into A. B divided into A. We are using B to divide A. And this is the word for the phrase. In the expression, of course, A divided by A divided by A divided by A is divided and B divided by A. These are the terms. Now, for these terms, let us do 2 or 3 examples to see whether we understand what we just explained. Okay? Are you ready? Let's do it. Let's see how to put all this together to check whether we understand those basic explanations. The first one said, okay, we said translate each of the following phrase into algebraic expression. The difference of 20 and 4. The difference of 20 and 4. So 20 comes first. So we have 20 minus 4. Difference is minus. Very easy. The quotients of 11y and 3. The quotient means what? Division. So we have 11y by 3. Or you say 11y ratio 3. This is very easy, right? The third question. 8 is more than t. Is more than t. This means that 8 is added to t. It's more. 8 is more than t. So, which means we have t plus 8. We have t plus 8. Okay. The next one. 14 less than 6p. Be careful here. 14 is less, which means 6p is the boss, is bigger than this guy. So which means it should be 6p less than 14. This is very important. Don't say 14 is less than 6p. It's wrong. 14 is less, not up to this guy. So look, this guy is boss. Why am I not this guy? Very easy, right? Let's do the next one. 3 times. 3 is multiplying, right? The sum of a, x, and y. Now, let us be careful here. This is 3. This is times. Sum means addition. But sum of what? Sum of x and y. 3 is multiplying the sum of x and y. So this is what? 3 is multiplying the sum of x and y. Are we together? It's very easy. It's very easy. You just have to understand. And if you like, you can open the bracket. But this translation is what? 3 is multiplying the sum. Now multiplying. So they sum themselves for it to multiply. So if you like, you can write 3x plus 3y. This is expression. Now, Giovanni has nickels and pennies. This is money, right? In his pockets. Okay, it is good that his pocket. It's not in his in his shoe. Okay, this is pocket. Good. That's it. Giovanni, the number of pennies. The pennies he has is 7. Now, we are now reached the number now. It's 7 less than twice the number of nickels. The number of nickels. Now, let me be careful here. Twice. So the nickels we have is twice. That is, it multiplies itself. 7 is less than, so 7 is not up to the twice of nickels. Right? Now, the next said, they want to help us. They say, let n represent the number of nickels. So which means, the number of nickels is n. So twice, that is 2n. Twice of nickels. That is 2n. And now they say 7 is not up to 2n. It's very easy. Very easy. Very easy. So, twice means, okay, let me write it, make it easy. Twice the number of nickels means, because it's n, that is 2 twice. That is 2n. This is twice. Now, the number of pennies is 7 less than. So, which means 7 is not up to this guy. Just like what we did here. 7 is not up to this guy. That is 2n minus 7. Because it's not up to. Which means this guy is the boss. And 7 is not up to it. If you say 7 is more than, you have to add. So it's not up to. And that is it. Very easy. Very easy. What problem you need to read, try to understand, and all those terms I explained for you before, you can solve more problems using this idea. Understanding is done. I think enough of expression, algebraic expression. Let's look at some types of algebraic expression and how to tackle them. Okay? The types. We have monomial, mono, 1. The terms is 1. Binomial, bi means 2. The first term, the second term. Trinomial, 3 terms. The first term, the second term, and the third term. Polynomial, inside this polynomial, we have monomial, we have binomial, we have trinomial, we have quadrennial, we have sextillion, and so on. So this is their father. They are all inside here. Now, what is not here? We have multi, that is difference. Multinomial, that is different. But this one, we are not looking at it now. We are going to look at it later. But what makes it multi? We have different type. Fraction, numerical, we can have more. Okay? So now let us take it one after the other and deal with it in this. Are we ready? Let's get to work.